So for example number 2, what you need to understand is a regular polygon can fit inside of a circle. So the circle can have a center. Okay? And a regular polygon, so when we go from the edge of the circle to the center, we would call that the radius, right? And if we go from the center of the circle, we would call that the radius. From the center of the circle to the edge, that's the radius of the circle. But now, a regular polygon, you can continue that okay? And what happens is, if you connect those ends, it makes a regular polygon. That fits inside of a circle. Now it's kind of hard to see because of the way that I drew my circle, so I'll draw the polygon out. Okay, so in other words, if I go like this, so this has 1, 2, 3, 4, 5, 6, 7, 8 sides. So that has 8 sides. And then this right here, from the center to the vertex, that's the corner of the polygon, is what we call a radius. And if you notice, it divides it up into 8 triangles. So if I take any one of these triangles, and I'm going to blow up the triangle and make it look bigger, from these are also these are the worst pencils ever, by the way. So this and this is congruent, and those are the radiuses. Now, if you take what we call the perpendicular bisector, we call that the apothem. Now you can calculate the apothem using the Pythagorean theorem. But the reason I go through all this with you guys is that to find the area of any regular polygon, okay, there's a couple of things that you got to do. One is, this is a central angle, okay? And so the formula to find the central angle is your central angle is equal to 360 divided by the number of sides, right? Because that makes sense. A full circle is 360 degrees, right? So a full circle is 360. If I take, there's 8 triangles in this octagon, and so that means I'll have 8 central angles. So if I wanted to find the measure of the central angle, and we'll just give this a label, we'll call this M, P, and N. If I wanted to find the measure of angle MPN, that would be equal to 360 divided by 8. And if you give me a second with the calculator, I will tell you what that is. 360 divided by 8, that's 45 degrees. Okay, so this central angle is 45 degrees. So I did all that because in example number 2, they give us a 5-sided polygon, so they say and these are regular polygons. I probably should say that. So this is a regular polygon. Regular polygon means that it fits inside of a circle and that all of the central angles are congruent, therefore all the vertices are congruent and all the side lengths are congruent. So this is congruent, this is congruent, this is congruent, this is congruent, this is congruent. This, and this are congruent. Okay, those are regular polygons. So all these problems are regular polygons. So then we'll label this as A, B, C, D, and E. And the center of this polygon is F. And then they have this little thing here where the apothem is G. Okay, so they want to know what's the measure of angle AFB. So from A to F to B, that's just going to be 360 divided by the number of sides. So it's 1, 2, 3, 4, 5. So this is a 5-sided polygon, which is a pentagon. And so then I'm going to say 360 divided by 5 is equal to 72. Then they want to know what's the measure for angle AFG. Well, AFG from A to F to G is actually 1/2 that. So that is equal to 1/2 the measure of, because it's a perpendicular bisector and it's an angle bisector, so it actually cuts AFB in half. So it's 1/2 times the measure of AFB, which is equal to 1/2 times 72, which is equal to 36 degrees. Okay, and then lastly, we're going to do GAF. Ooh, that's a tricky one. So the measure of GAF. Now this one's tricky because if I look at GAF, I'm going to go from G to A to F. So here's G, here's A, here's F. I want to know what this is. Well, I know that this is 90 degrees. And I know that this angle here, so this is, we just figured that out to be 32 degrees. This is 90 degrees. And so all 3 sides of that triangle have to add up to 180. So we're going to say 180 minus 90 plus 32. So that's going to be 54 degrees. And that's it.